For the most part, when you're solving inequalities, you can use exactly the same steps as you would use when you are solving equations. The only difference is that there are certain circumstances under which you need to flip the inequality, and by that I mean change the sense of the inequality or change the direction of the inequality when you multiply or divide by a negative number. So let's see why that is. We're going to use as our basic inequality 2 is less than 4, and we're going to do some things to it and see what happens. I'm going to represent the answers here as an inequality, and here we're going to represent the answers on the number line. So let's start with 2 is less than 4, and we'll graph 2 and 4 on the number line. And then we're going to graph what happens when you multiply by 2. So first, if we multiply this inequality by 2, we get 4 on the left, 8 on the right, and we can see that the inequality should still go that way. 4 is less than 8. And on the number line, 2 and 4 would become 4 and 8. So 2 becomes 4, 4 becomes 8. And you notice that 4 is still to the left of 8, just as 2 was to the left of 4. Now let's look at dividing by 2. So if we divide both sides of 2 is less than 4 by 2, we get 1 and 2, and 1 is less than 2. Again, if we start with 2 and 4, and then we divide by 2, we get the results 1 and 2. The 4 goes over here, 2 goes there, and you can still see that 1 is to the left of 2. Now let's look at what happens when we multiply and divide by negatives. So if we multiply by negative 2, the left side becomes negative 4, the right side becomes negative 8, and now we see that negative 4 is greater than negative 8. And on a number line, this would look like this. We start with 2 and 4, and then if we multiply by negative 2, the 2 becomes negative 4, and the 4 becomes negative 8. And we've seen that the sides switch places. Here, this number is to the left. Here, it's to the right. And the same thing would happen if we divide by negative 2. So negative 2 becomes negative 1, or rather 2 becomes negative 1, 4 becomes negative 2, and we again see that negative 1 is greater than negative 2. And on the number line, when we start with 2 and 4, and then the results are negative 1 and negative 2, we can see that the numbers switch places on the number line, left and right. So let's see an example of how that might be used when you're solving an inequality. We'll take a very simple example. Let's take negative 2x plus 3 is greater than 9. So if we were solving this, the first thing that we might do is subtract 3 from each side. So we'd subtract 3, 3, and subtracting 3 from each side is okay. This would leave negative 2x is greater than 6. And then when we divide by negative 2, so we'll take negative 2x divided by negative 2 and 6 divided by negative 2, we need to switch the inequality, and then we'll find that x is less than negative 3, and this would be the solution. Now, we can test this just to make sure. So we want to test numbers like -4 and -2. And since -4 is less than -3, this should be correct, and -2 should be wrong. So let's check it out. -2 times -4 plus 3 is greater than 9. -2 times -4 is 8, plus 3 is greater than 9. 11 is greater than 9. So -4 works. Now let's check -2. So -2 times -2 plus 3 greater than 9. This would be 4 plus 3 is greater than 9. 7 is greater than 9. Well, that's incorrect, but that's what should happen because -2 is not a solution. So the lesson is that when we're solving inequalities and we multiply or divide both sides of the inequality by a negative number, we reverse the inequality as we did here and here.